Hello students, continuing the chapter electricity, the next topic is electric power. So if we have to define power, we know power is what? Rate of doing work. Now what happens when an electric current flows through a conductor? Basically we know that due to there is a work done in moving a charge, and work done is nothing but energy. So you can say that when electric current is moving in a conductor, then electrical energy is being consumed. Whether the fan is running or a bulb is being lit up, what is happening? Electrical energy is being used. So you can say electric power is nothing but electric work done per unit time. So formula becomes P is equal to work done upon time, that is W by T. Unit of power is watt. Watt is nothing but joule per second. The other unit may be kilowatt, that is 1000 watt. So basically what we mean, if anything is rated as 100 watt, that means it is using 100 joule per second. It is consuming 100 joule energy per second. So if you will see any electrical appliance, there the reading is given in watt, and that decides what is the resistance of that particular appliance, because we know that the voltage that is being supplied in a home is fixed. Now we can also say that electric power is rate at which electrical energy is being consumed. Means what I told you earlier, if the bulb is rated at 60 watt, that means it is consuming 60 joule energy per seconds. Now what happens when an electrical appliance consumes electrical energy at a rate of 1 joule per second? It's said to be 1 watt. So it may be taken as the definition of 1 watt, that when an electrical appliance consumes electrical energy at rate at 1 joule per second rate. So if we go on with the formula of power, then P is equal to W by T. What is W? Work done. Now let us recall where we have studied work done. So if you remember, then in the topic electric potential, we studied about work done. That was work done in moving a charge from one point to another. So basically in electric power, what is happening? Electrical energy is being used, or you can say that the work done in moving the work done when the charge is moving inside the conductor, and that work done when divided by time gives us the idea about power. So V is equal to W by Q. So W becomes V into Q. From here you can see that V is equal to W by Q and W is equal to V upon Q. Also the next thing is that we need to replace the value of Q. Here we want to take something in current. So if we recall the definition of current, then current is what? Rate of flow of charge. So we can write I is equal to Q upon T. I is equal to Q upon T. That gives us a formula Q is equal to IT. Now Q is equal to IT and W is equal to V into Q. So if we replace Q by IT, we get W is equal to V, I and T. Now this becomes the formula for W. If we put this VIT here in this equation, then we get P is equal to VIT upon T, that is equal to P is equal to VI. Now this P is equal to VI is nothing but the standard formula for power. The formula is P is equal to VI. Now by Ohm's law, we know V is equal to IR, and we can also write I is equal to V upon R. So from here, the same very equation P is equal to VI, we can get two more formulas. If we replace V by IR, we get P is equal to IR into I, that is equal to P is equal to I square R. And if we replace I by this equation, that I is equal to V by R, we get a equation that P is equal to V square upon R. Now I is something that cannot be taken as fixed, because different appliance with different rating would have different current. But because we know that in domestic circuit all the appliances are connected in parallel, but the voltage is always same. And we also know that in parallel connection the voltage is same, and in our home the standard supply is of 220 volt. So if we take V as constant, then we can get that power is inversely proportional to resistance. Now by inversely proportional to resistance, what does it mean? That the resistance of high power devices is smaller than the low power ones. For example, if we talk about the resistance of a 100-watt bulb, if you calculate at a 220 volt standard supply, it would come smaller than that of the 60-watt bulb at 220 volt. So you know P is equal to V square by R. So you can write R is equal to V square upon P. Now V square will be 220 to 220 upon P. If the P would be higher, the resistance will automatically come lower, and if P would be lower, the resistance will automatically become higher. So you can say that the resistance of the high power devices is smaller and the low power devices is higher. Let us see a numerical. So if we go to numerical, then there is a numerical that an electric bulb is rated at 220 volt and 100 watt. When it is operated on 110 volt, what is the power consumed? So in first case, let us see P is equal to 100 watt and V is equal to 220 volt. Now R is equal to what? So we know that formula P is equal to V square by R. We'll just put in the, we know P, we know V, we can easily find R. So R becomes 484 ohm. Now it is said that what will be the power consumed if the voltage level is decreased. Although the voltage level is being decreased, but the bulb that is being used is same, so the resistance of the bulb would not will not change. So resistance of bulb will be unchanged. So P is equal to what? We have to find V is equal to 110 volt. So again, by the same formula, P is equal to V square by R, we get power to be 25 watt. So what we have observed is that if the resistance is same but the voltage level is decreased, the power also gets decreased. So you can what we'll do is in next class we'll study about electrical energy, because we have seen power, and power is nothing but the electrical energy consumed, and we'll also see the commercial unit of energy, which is very important because that would help us to calculate the bill at our home. So I would request you all to practice more numericals, because the next topic that we'll cover will have very good numericals that would help, as I told you, in calculation of the electric bills as well. Till then, thank you and stay safe.